Hey guys, welcome to the last lesson in Unit 5. We're going to end the unit talking about domain and range. So your aim today is that I can determine the domain and range of a function by looking at its possible inputs and possible outputs. Ultimately, all functions do is convert inputs into outputs, which is what we've been doing this entire unit. So each function has two sets associated with it. Those things that serve as inputs and those things that serve as outputs. These sets are given names. We call it the domain and we call it the range. So simply put, the domain is a set of all inputs. We call all of the domain, all of the inputs, you can also say x values, your domain. The range of the function is your set of all the outputs, which are all your y values, and we also call them f of x values. So domain and range. Domain is x, range is y. Okay, it's a very simple concept, so let's take a look at some ways we use it. Exercise 1. Consider the function y equals f of x shown on the graph below. So this right here, this curvy line, is f of x. Evaluate each of the following: f of negative 3, f of 1, and f of 3. So remembering that when we're evaluating this negative 3, that's your x. So we're going to go to the graph and find negative 3, 1, 2, 3, which is right here, and then find the corresponding y value on the graph, which is right here. So this is the point negative 3, 1. So f of negative 3 has a y value of 1. F of 1, we're looking for an x value at 1. So here's the x value at 1. And I'm going to find the corresponding y value, which is here at negative 3. So f of 1 is negative 3, and that's the y value. Finally, f of 3, that's your x. So I'm going to find 3 on the x, so 1, 2, 3, and go up to the graph, and that is at 1, 2, 3, 4, 5. So I have a point at 3, 5, so f of 3 is 5, and that is my y value. Can the function rule given by the graph, right, the rule is this graph, we don't have an equation, but we have this curve, give you a value when x equals 5? So I'm going to look on my graph and say, okay, well, I'm going to find x equals 5, 1, 2, 3, 4, 5. So there's x equals 5, and I notice that when I try and find a y value, oops, oh my god, well, I can't make a straight line. When I go to find a y value, does that line ever hit my graph? Does it ever hit this curve? No. So there is no y value when x equals 5, because it never touches the graph. Okay, so what does that mean? When we talk about question C, is x equals 5 in the domain of the function? The answer to this is no. It's not part of the possible input values. 5 is an impossible value to put into here because it has no output. So when we say something's part of the domain, remember, from the definition, is all possible x values. And here, 5 is impossible. So when I give my answer to this question, I'm going to say, no, x equals 5 is not part of the domain. So D says, give two other values of x that are not in the domain. Well, my graph starts here and it ends here, so I can pick this point. It won't ever cross it, so notice x is 4 won't ever cross it, and x equals 6 won't ever cross it, and way over here at x equals negative 6 won't cross it. So at 4, 5, and 6 and negative 6 are all places of x where it won't ever cross it. So I could say, okay, x equals negative 6 and x equals 4 are also not part of the domain. I could be crazy and even say x equals 100 is not part of the domain. Even though 100 is not on that graph, I know the number 100 exists somewhere, but I know that it won't be part of this domain because it'll never cross the graph. All right? Letter E, circle the following y values. Now we're thinking about y values, and they're all listed down here, the possible y values, that are in the range. So remember, range from our definition are all possible y values. So now I'm going to change my thinking a little bit. X values I often think of from left to right, and I'm going to be clear about that. So when I think domain, I want to think left to right, because the x-axis is here, and that's thinking left to right. But now I'm thinking about y values. In y values, you're going to think bottom to top. Oh, that's nice. Bottom to top. Now you're kind of switching your thinking, and now you're thinking from the bottom of the graph to the top of the graph. So when I look at my graph, and how about I do you guys a favor here? I'm going to erase this stuff. We don't need it anymore. Okay? And the first thing I'm going to think about is I'm going to think about y equals 0. So y equals 0 is this line right here. Does this line cross any x values? Yep, right here, and right here. So is it part of the range? Yes, because it hits the graph. Y equals 6. 1, 2, 3, 4, 5, 6. Does this line hit the graph? Nope, so it's not part of the range. Y equals -1. Right here. Does that hit the graph? Yep, right here, here, and here. So y equals -1 is part of the range. Y equals 3. 1, 2, 3. Draw a line, and it hits it right here. So y equals 3 is part of the range. -5. 1, 2, 3, 4, 5. Does this ever hit the graph? Nope, so this is not part of the range. And y equals 4 hits right here, so it is part of the graph at y equals 4. Another way to think about this as well, I'm going to erase what I did a second ago here on here. So I'm going to, wait, I need a way bigger eraser than that. So another way to think about this, thinking about this whole bottom to top, left to right thing, if I look at this graph and I think left to right, the farthest left point is here, and the farthest right point is here. The x value here is -5. And the right value here at x is 3. So I know that x can only be between -5 and 3. This is one way to think about your domain. And then I know that anything below -5 or above 3 isn't included. Same thing for the range. If I go to the very bottom of the graph, which is this point right here, and that y value is -4, and then the very top, which happens to be this same point, but the y value here is a 5, I know that my range has to be between -4 and a +5. So anything above 5 or below -4 is not part of the range, which is why I crossed off -5 and 6, because 6 is greater than 5 and -5 is less than 4. Okay, so I really want you guys to write these two things down. It's really important. The range, all y values, think bottom to top, and the domain is all x values, and you're kind of thinking left to right here on your graph. Okay. Finally, F. Oh, I already did that. I did that here actually. Write the domain range using a single inequality. That's basically what I did here. So here's my range: -4 less than y less than 5. You could also write it this way: -4 less than or equal to f of x less than or equal to 5. You'll see it both ways, so be careful. And then for the domain, we had it up here. -5 less than x less than or equal to 3. So -5 less than or equal to x less than or equal to 3 is my domain. Okay? And again, what do you do if you don't understand? You mark it on your notes, and you come to class and you ask one of your teachers. Alright? Okay, let's go to the next page. Exercise 2. Given the function f of x equals x over 2 minus 3 and the domain shown below, fill in the range. Write the set in roster notation. So we're given a domain, which again, like what we say, what are the domain? The domain are your x values, or we also call them inputs. They have lots of names. To figure out an output, which is your range, what do we have to do? Well, we have to plug all these in. And my pen just did that thing it did again. But I hate that it does. Okay, so we got to figure out -4, 6, and 10, plug them into our equation, and figure out our output. So I'm going to do each one. So the first one, f of -4, I'm plugging it into this equation up here. F of x equals x over 2 minus 3. So f of -4 is going to be -4 over 2 minus 3. And I'm going to simplify. So -4 divided by 2 is -2. And -2 minus 3 is -5. So I know that that is one of my inputs, -5. So I'm going to put it into the range. Okay, so that's -4, check. Now let's do f of 6. That's my next one. Again, I'm going to plug it in, so I get 6 over 2 minus 3. So f of 6 equals 3 minus 3, which simplifies to 0. So my next range value is 0, so I'm done with f of 6. Now finally I have to do f of 10. So f of 10 is going to be 10 over 2 minus 3. 10 over 2 is 5, and 5 minus 3 is 2. So that's my last range value. Now, this is an interesting example because in this example, we only have 3 inputs and 3 outputs. So we can't write this range the way we wrote this. See how on this one we wrote it like, oh, x's and y's can be any number between -5 and 3. But in this case, we only have 3 values, so we write it in roster notation, which looks like these 2 squiggly lines, and then you write each number separated by commas, okay, and say that these are the only 3 values that can be used. -4 doesn't count, 1 doesn't count, only -5, 0, and 2 are in the range. Only those values are in the range. This is called roster notation. And we use this for individual values. Okay? So kind of an interesting notation there. I don't think this should be something you've seen new. I think this is something you've seen before, but may need to review it. Okay? All right, exercise 3, multiple choice question. Which of the following values is not in the domain of the function shown below? So we're looking for one of the values that's not in the domain. Illustrate your thinking by marking points on the graph. So let's go through these. -3, and we're thinking domain, right? So domain is going to be what? Our x values. So we're thinking x values. So left to right. In fact, I'm going to write that here. Left to right. So -3, I'm going to find -3 on the map. 1, 2, 3. Does it have a corresponding y value? Yes, it does. So -3 is okay. It's part of the domain. How about -4? 1, 2, 3, 4. Yes, it's also part of the domain because it has a matching point on the graph. How about 5? 1, 2, 3, 4, 5. And here, this has no y value on the graph. Oops. Okay, so 5, that's our answer. It does not have a matching y. I could always check 0, and it's right here, so we're good with 0. So 5 is not part of the domain. Okay, so exercise 4, it's a piecewise linear function given by the formula f of x equals -x plus 2 over 2 from -4 to 2, and then 4x minus 10 from 2 to +4. So this already gives you the domain. Remember, domain are my x values, so my domain starts at -4 and it ends at 4. So if I have my domain is, it starts at -4 and it ends at +4. The best way to solve this problem is to make a table for all these values in the domain. So I'm going to make a table, and I'm going to try and find all the values I need. This is my range. I have to find these y values. So I'm going to start with -4, and I'm going to go all the way up to +4. I don't know how much room I need, so I'm going to go one at a time. So I'm going to start with -4, and I'm going to pick the equation I need for -4. Do I need the top one or the bottom one? Well, -4 is part of this first one, because that's -4 to 2. So all the integers from -4 to 2 need this one equation. Okay? So -4, -3, -2, -1, 0, 1, and 2 are all going to use this first equation. Okay? Then the numbers 3 and 4, they're going to use the second equation, 4x minus 10. Okay? So what we're going to do is we're going to plug them in. So the first one, I'm going to have -4 plus 2 over 2. That becomes -2 over 2. This is like having a little invisible -1, so when I multiply them I get a +2 over 2, so I get 1. So my first y value is 1. Okay. The second one is negative 3. I'm going to plug it in. Negative 3 plus 2 over 2. Negative 3 plus 2 is a negative 1 over 2. So this becomes 1 over 2, which gives me 1/2. So I can write 1/2 or 0.5. Either one doesn't really matter. Number 3. Number 2, let me just give myself some more space here because I didn't know how much these would take up. So I'm going to erase these real quick. The next number I'm going to plug in is number negative 2. And if you want to right now to pause this and try and fill out the rest of this table on your own, that might be a good way to practice this, making a table and finding all your values. This becomes negative 0 over 2, and 0 divided by 2 is just 0. So I get a value of 0 here. Next integer I want is negative 1. So I get negative 1 plus 2 over 2. That simplifies to negative parentheses 1 over 2. So I get negative 1/2 for this. Or negative 0.5, either one. Next I'm going to plug in 0. So I get negative 0 plus 2 over 2 equals negative 2 over 2, which gives me a negative 1. I'm going to plug in 1. So I get negative 1 plus 2 over 2, which gives me a negative 3 over 2, which is negative 1.5, or negative 1.5. Then I'm going to plug in 2. So I get negative 2 plus 2 over 2 to get negative 4 over 2, which gives me a negative 2. So all of these equations, I use this first one. Now I'm gonna finish the table over here on this side because I ran out of room. But for 3 and 4, what equations am I going to pick? I'm going to pick the second equation, this 4x minus 10 one. So because 3 is between 2 and 4. So now I'm going to plug 3 into 4x minus 10. So I have 4 times 3 minus 10, which gives me 12 minus 10, which gives me a 2. And then when I plug in 4, I'm going to have 4 times 4 minus 10, which gives me 16 minus 10, which gives me a 6. Okay? Now I'm going to graph this. I think that'll help me. So I'm going to write down the points that I just made. So I made the point. All right, so I'm going to go ahead and do myself a favor and make these into coordinates so I can make my graphing easier. So this coordinate right here becomes negative 4 comma 1. This coordinate becomes negative 3 comma 0.5. This becomes negative 2 comma 0. This becomes negative 1 comma negative 0.5. Oh my gosh. Okay, this pen. Negative 0.5, this becomes 0, negative 1. This becomes 1 comma negative 1.5. This becomes 2 comma negative 2. And then over here I get 3 comma 2 and 4 comma 6. Now this is important because the range has to be your smallest y value and your largest y value. It's kind of hard here to tell what that is until I get the graph of it. So let's plot these points. The first point is negative 4, 1, right there. Second point is negative 3.5, which is halfway there. Then I have negative 2, 0, which is right here. Negative 1, negative 0.5, which is right here. 0, negative 1, which is here. 1, negative 1.5, that point. And 2, negative 2. So I have a straight line going down like this. And then when I'm graphing my last 2 points, I have 3 comma 2. And I have 4 comma 6. So it goes up very sharply like this. Now I can find my range really easily. Because now my range is going to be, again, if I think about range, I'm thinking of bottom to top. So I'm going to look at my graph. Where's the very bottom of my graph? The very bottom of it is right here. And what's that y value? That y value is negative 2. So my very, very smallest range value is a y value of negative 2. So when I'm writing my range, negative 2 is my smallest one right here. Then I'm going to go to my very highest one, which is right up here, and that's a y value of 1, 2, 3, 4, 5, 6. A 6 y value. So my range is -2 to +6. And I could see that in the table too. If I look in the y for the highest value, look, 6 is my highest value. What's my lowest value? -2. So graphing it wasn't necessary, but I'm a visual person, and I needed to see that graph to make sure that I knew what my lowest and my highest was. Alright? Yes, this problem was a lot of work. I should see this kind of work on problems like these if you have to make a table. Especially on a piecewise one that you can't put in your graphing calculator. If this had been not a piecewise function, you could have put this in your calculator and gotten the table on your own. Okay, and I think in your fluency there are some problems that ask you to do just that. Alright? Remember, ask for help if you need it on your notes, and good luck on your fluency.